Hey everybody, welcome to today's webinar. It's all about leading a high-stakes database migration. Shortly you'll be joined by Miles Ward. But before we get to that point, just want to give you some housekeeping ideas or rules. This webinar is being recorded, so if you need to step away for whatever reason, don't stress. We've got you covered. The webinar will be emailed out to you at the end of the show. If you've got any questions, make sure that you ask them in the Q&A panel, and we'll endeavor to get to those questions during the webinar. But if not, we'll also reach out to you afterwards if you've got any specific questions about ScyllaDB or whatever the case might be. Make sure you ask those questions, and yeah, we'll get started shortly. Okay, everybody. G'day again. My name is Tim, and it's my pleasure to introduce today's guest speaker, Miles Ward. He's a technologist who truly needs no fluff in his title. Miles is the CTO at SADA, where he leads cloud strategy and innovation for one of Google's top cloud partners globally. Now, before SADA, he helped build the cloud practice at Google itself, where he played a key role in driving adoption across some of the largest and most demanding workloads in industry. He's got a background that spans from startup scrappiness to enterprise scale architecture. Miles brings deep expertise in cloud migration, which is what we're talking about today, data engineering, and building systems that don't fall over under pressure. He's known not just for his technical chops, but also his ability to communicate complex ideas, which we'll hopefully see today. He also plays the horn. One of is the sousaphone, I think, is it right? Sousaphone. Anyway, yeah. So be sure to check out his personal website. There's lots of entertaining stuff in there. Definitely worth a listen if you want to feel those Winamp vibes from the late 90s and early 2000s. Big welcome, Miles.
Thank you so much, Tim. I really appreciate it. We are not one of Google's best partners. We are the best. We are partner of the year back to back to back to back to back to back. So I think if a seven-peat doesn't speak to total mastery, I'm not sure what does.
Yeah, and I see what you did there. Obviously, coming from Google and then making the best Google partnership out there. So yeah, well done, nicely played.
Well, and came to Google from AWS. So, learned cloud and scalability from some of the real original champions of that, and then got retaught by Google. There's some truly magical systems that sit at the center of that platform that make all of what we're talking about today way, way easier. So it's an easy position to be at SADA, representing that platform to customers.
Awesome. Well, I'm really looking forward to it. But before we get into it, I just want to have a few slides from us here at ScyllaDB. We're obviously a database company that's built from the ground up to take full advantage of modern infrastructure. And unlike legacy databases that really struggle to sort of keep up with modern hardware, ScyllaDB is designed to exploit multi-core processors, fast NVMe, local storage, and high-speed networking. And that really helps us deliver predictable performance at any scale. So with millions of operations per second and ultra low latency, we really help ensure that those applications are running with unmatched efficiency. And we also achieve, massive scale with far fewer resources, which obviously reduces infrastructure costs and handles demanding workloads across the globe. And if you're wondering, whether ScyllaDB is actually the right fit for your own workload, let's take a look at some of the teams or the kinds of teams that typically use our database. Now, these are engineering teams that are dealing with, high or rapidly growing throughput. They tend to have strict latency SLAs that they can't afford to miss. They're actively looking to perhaps reduce their cloud infrastructure spend and footprint. I think that might be a theme today as well. They don't want to spend time babysitting the database. They want something that just works. And they tend to work with structured or semi-structured data, which makes it a really nice access pattern that we can work with to help them scale. So if any of that sounds familiar, then congrats, you're definitely in the right place today. If not, stick around as we might be able to help you join the dots anyway. And one last slide before we kind of get into it. What you're looking at here is the favorite snapshot of companies that ScyllaDB helps in production. And what's interesting, it's not just the big names that you can recognize on the screen there. One common thread is that they all need a database that can handle speed, reliability without becoming a bottleneck in their applications. So enough with the fluff and in with the meat and potatoes. Let's start with a question for Miles. Given I've just convinced you of all the wonders of ScyllaDB and you're ready to make the switch, what are the actual reasons why people consider a database migration to begin with? Because it's not always about switching vendors, right? There's got to be other reasons.
Sure, I thought you did a good job of laying out what are technical drivers for most customers, but there are, in many cases, far more important in their decision-making business drivers that are more important than that. So plenty of our customers looking for a platform that's open, that sets them up to be able to interoperate across all the different cloud providers. We have lots of customers that are interested in making sure that they can really do the kind of direct testing and it's not a black box to them. So some of the highest volume databases and data systems in the world are all built on proprietary tools that are managed by the hyperscale cloud providers. That makes it just very difficult to feel like you have end-to-end operational ownership over the commitments that you're making to your customers. We also have a lot of customers that are thinking really hard about about the overall architecture for their systems. And one of the, I think, superpowers inside of what's been done in ScyllaDB, because it has the ability to impersonate multiple different database systems, right? Through the, being able to behave like Dynamo through the alternator layer, or being able to behave like Cassandra. That focus on flexibility and interoperability also sets up folks to be able to run fewer databases, right? Plenty of the customers that I talk with consolidated down from 3 or 4 different layers because of the better performance down to maybe just 1 or 2, which is a real operational and complexity saving. So if those maybe sort of more business drivers match up with the technical advantages that exist, I think you have customers in, either in their development and product teams or in the IT teams that are weighing both of those sets of issues very carefully. And like anything, a lot of this is also about ambulance chasing. Sometimes databases break and they puke and die, and companies screw you over in negotiations and set you up for bad outcomes. And that's always a time to come up for air and look around and take stock of what's going on and figure out if there's a better alternative.
Yeah, absolutely. I think ambulance chasing, as you called it, yeah, that was definitely at the top of my list. I mean, we just because we see a lot of customers with some type of compelling event, they've already got things are breaking in production. It's often like a good reason why they might be switching databases. But you mentioned some other things there, like architecture complexity, reducing the footprint. I totally agree there. I think. Do you think it's I'm a bit wary. I mean, yes, ScyllaDB can impersonate other databases. Like we have a great internal cache, for example, like in terms of replacing Redis. You mentioned DynamoDB, our alternator API, so that, fully compatible with DynamoDB. They're good reasons. But I guess more recently, especially with AI, have you seen, I mean, to me, there seems like an explosion of databases, right? You go into any organization and they're running like not just a couple anymore. It's like 10, like time series databases, caches, relational data, So it's sometimes perhaps a bit of is it a fool's dream to kind of think that you can consolidate all of that? Like, is it just a fact of life you're going to have many different databases? Is that what you're seeing out there in the industry?
Well, I mean, entropy is going to lead to the heat death of the universe over time. That's where we're all going to end up. And in this brief window of our lives, our job is to fight desperately against said entropy. And so our friends in the business office, they make choices to try to solve that problem at their layer. Sometimes that's about mergers and acquisitions, dragging new companies in. That's a huge driver of the complexity that exists. Some of this stuff happens on purpose, but most of it happens because some of the suits did something and now it's yours to manage. So we also have a lot of places where companies, I think it's easy to imagine that everybody's building all of their software, but they're not. They're pulling down instruction manuals from somebody else and implementing some commercial application that they've been told they have to. So if it says in the instructions you got to run this database of this point release, guess what? Now you're running that in production. So I think for many businesses, they end up in a place of extreme operational overhead through a lack of sort of rigid rules and technical leadership at the top. There are some businesses that have avoided that kind of thing because they've had aggressive structural technical leadership at the top. I think like an easy example there is Adrian Cockcroft from Netflix, just laying down the law about how they're going to build and doing so in a way that simplified their platform to an incredible degree. So it's not something that happens because they want to. It happens because of reality.
Yeah, that's been my experience too. Sometimes you have, it depends on the leadership, doesn't it? Like who the CTO is, and maybe they're trying to reduce technical debt. Maybe it's
And
just
where
like a
they sit
spend
in the
thing.
power dynamic, right? Like
Yeah,
if the technology organization has produced a whole bunch of profit for the business, guess what? They get to make some of these kinds of calls. If they haven't, and most of the profitability of the business is coming from the business unit and they're off making these kinds of calls, then the technology gets to come along behind and clean up the mess.
yeah, and I guess another driver is, you know, databases in certainly large organizations can be a significant spend, right? Like it's so quite often, well, I imagine there's a lot of reasons. It's just not only just reducing that cost, but because it is such a big part of the IT budget. Is that what you're saying?
I mean, SATA today represents, multiple percentage points of the global GCP consumption. Databases is on the order of tens of millions of dollars a month. So,
Yeah,
databases are a big business,
yeah,
and for a lot of our customers, this is just the cloud part of their database spend, let alone what they've put on top of compute as software or bought through SaaS vendors that doesn't show up in their cloud bill. It is a material part of overall costs. It is one of the costs that tends to get non-linearly worse over time. You put
yeah.
more data in, maybe twice as much data. It's not like you just need twice as many computers. Maybe you might need 4 times as many because the licensing rules or the way that the chattiness of the application works or the nature of the normal queries that you run. So it's not when you're building a business on top of technology, you're trying to get sublinear scaling. How do I make it so when I get new customers, it costs me less per customer? And runaway database costs are one of the kinds of things, along with like egress or sort of bad management and storage, where you can get to super linear costs, which is just what none of us want.
Yeah, so like egress, you're talking about the actual network traffic costs, right?
Sure.
Getting,
Yeah.
yeah. And especially I guess if people are doing more stuff on a global scale as well,
Oh
that,
yeah.
that can really
Yeah. No,
start to
that stuff
stack
just
up, right?
explodes.
Yeah, yeah. So I guess we covered the reasons why. I had some notes here: cost, complexity, version upgrades. I've done database migrations in the past just because incompatible major version upgrades, and you need to replace the whole master or whatever. So there's a bunch of reasons, and I think sorry, yeah, it's all good. I thought my dog was coming up the stairs there. Yeah, there's a bunch of reasons. But the other words in this webinar title were high stakes. High
Sure.
stakes. It implies like a risky thing. I guess it's always high stakes, right? You've never been in an organization where they're just like, meh, it's our database, right? It's always important to the business some way, somehow. So it's always going
Yeah,
to be a high
or to
stake
the people
operation.
involved. I mean, I think I've been in rather extreme versions of this where like I was at AWS during the Judgment Day outage. One of the customers I was on the phone with ran a home health monitoring service. So if their service went offline, no one would die. But if someone went into cardiac arrest while the service was down, no one would know, which is
Yeah,
maybe kind of just right next to killing people when the
yeah,
application's offline. So that sounds like a thing you might want to have, like some availability design, some redundancy. They, of course, had implemented 100% of their technical systems on a single EBS volume in US East, which is
Ooh,
how you know that you haven't done it right. That's why we ended
Yeah.
up writing things like the well-architected framework to teach people how to build systems that are highly available. I know Scylla follows that stuff to the letter in big implementations with customers. So
Yeah.
there's a lot where sometimes the stakes are about about life and death. And like we just got done doing a big project at SADA with the folks at the Weather Channel. Their mission is to save lives by giving people better information about the weather. That makes all the tools we're building there life and death kinds of tools. But I would say that most of these things feel like economic decisions. If I screw this up, I'm going to piss off most of my customers, or I'm going to attrit customers to my competitors, or I'm going to miss the business opportunity of growth together with those customers over time. And and all of this comes down to trust, right? If for 100 different reasons you can screw your application up in a way that breaches the trust of your stakeholders, whether they're customers or internal users or the rest. And so doing careful planning, being thoughtful about the migration process, having the right kinds of design for that, set everybody up to grow trust as opposed to erode it.
Yeah, so I guess we're sort of dipping in towards the how we do these migrations. We've established that yeah, it's generally always high stakes, right? Like you said, it can be life or death in some situations, but more likely economic, as you said.
Yeah,
Um,
if you're the brand new intern that started last week and somebody gave you the database to migrate for dumb internal demo app number 7, and it's your job, it's high stakes to you. You're gonna look silly in front of your boss when you screw it up, right?
yeah,
And probably
yeah.
pretty important to you that it gets done right.
Yeah, I can't ever think of any engineer in history which has taken, a database migration, you know, lightheartedly. Like they're just, I'm sure, it doesn't matter if you got 1 million records or 50 billion records. Like it's always like high stakes in context is what I'm trying to say. So this is just not something that applies to, those big logos that we had at the start of the webinar. It applies to everyone, like all size startups or businesses. They're all impacted. Like it's inevitable, right? You're going to be doing a database migration at some point in your engineering sort of career, whether you're an SRE or you're in charge of platform or you look after cloud. Like it's likely one of your tasks that you have to do, right?
Yep.
Yeah. So maybe we can talk about what are some good sort of migration patterns that you see. I mean, obviously the one that people would think of first up would be like Big Bang, but there's obviously other ways to approach this, right? To sort of de-risk and we'll take the risk out of this sort of migration. What's some of the things that you see that work well?
Sure. There are a whole bunch of schools of thought around the sort of labels for methods on this stuff. Every different culture and continent and company tends to interpret those things on their own. And so I'm a little hesitant to describe any one of them as as like patently better than any other by name,
Yeah,
because that doesn't work, right? Everybody's going
yeah,
to misinterpret what I'm talking about. So in terms of approaches, a couple things that have repeatedly been important. One of the things that always is important is to work out, and to do enough formal discovery around the process to identify all of the upstream and downstream dependencies for the systems that you're working, and to get a clear sense of what happens as services interrupted to each of those systems. If you don't have an idea of what the consequences of your change are and what the real limitations look like, you're going to design a migration that's ignorant of those needs. So whether that's heartbeat health checks on applications, or how long are you allowed from a business contract standpoint to take a system offline, things like that all affect the design of your migration. Another critical piece, I think very often companies have a tendency to want to like start small and let's figure out our training wheels. The reality is we find over and over again that the correct method is to start with the hardest, ugliest one first, because you're gonna be wrong in terms of estimating timelines and noodling through the sort of nuance of who has the correct skills for each of the steps, and how does resource management work, and what are all the sort of edge conditions that drive complexity. If you do the hard one first, you learn a lot more about all of those issues, and you can apply them more confidently to all the subsequent migration components. Almost no company has all of their data in exactly one database and is now about to move it to exactly another database. They all have dozens of them, and they're in a half dozen different point releases, and some of them have the same stuff and some of them don't. So the more that you identify whatever you think is the scary one, you also get this emotional benefit in your teams that like, that one's done. Everything else after this is going to get easier. We've already worked out the kind of hardcore playbook. We can now use the heavy tooling playbook for the easy, smaller database. Oh, that means that one's going to be super easy and straightforward. I think that it tends to work better interpersonally as well as technically. It's also, I think, a super important bifurcation, kind of two different strategies here to evaluate. Depending on how deep you think the kind of mortality of wound around a failure of this migration looks like, that you got to get a clear decision together with your business and technical stakeholders around making the investment to tolerate rolling back. Right. And the most sophisticated, most advanced migrations in the world, I think I'm using the example in my head of Google's migration from its internal data system that backed Gmail to Spanner, their larger data system that backs things like ad in queues and does trillions of transactions a day. That migration took something like 7 years. They wrote Spanner to do that work, to give you a sense of how big that task was. And they were able to do roll forwards and rollbacks of individual mailbox migration for over 2 years before they finally finished and decided that performance and reliability and consistency in every part of that was best in the new environment, and started to decommission the old one. That is an extreme investment in the availability and reliability of your migration process. They are building an enormous amount of software just to run the migration for that one migration. I think most companies don't have a workload with 2 billion users on it, and which underpins a giant $1 trillion global multinational. And so you may make a decision to have a somewhat more tight wire act migration. I think critically, the basic steps that you follow around high availability design should be reflected in your migration design. All the stuff that you would do to keep the system online when you're not changing it, you should definitely be doing that stuff while you're changing it. So, so that if you run into a problem, you can get back to a healthy state without too much interruption.
Yeah, lots of great advice there. I think like when you're talking about dealing with the scariest or the ugliest ones first, that sort of lends itself to that, that phased or iterative approach towards migrating piece by piece, if you can do that. But I think the other great point you made there, or a couple more good points, but the discovery process, that can be quite difficult, right? Because databases have been in production in your business for sometimes years, and just understanding what connects to it, what microservices are hooked up to it. Wasn't there like an example at Twitter or something where they started decommissioning databases and forgot that the building pass was linked up to it and they couldn't get in? So
oh yeah.
yeah.
I mean, I worked with Twitter, sort of before it went nuts, and led their migration from bare metal data centers onto GCP. That was 362 petabytes active, ran over an 800 gig a second interconnect from their environment into Google's facilities. 800 gig a second is like, it's like most of the throughput of the internet at the time. So pretty, it took 43 days to move their data over the wire. And that was more a data warehouse migration. So there are some advantages for our friends in warehouse land where maybe you aren't running hundreds of thousands of analytical queries a second, and you don't have the same kind of transactional loads, but they had all of their ad systems ran on top of the warehouse, all of their ability to earn revenue therefore sat on top of the warehouse. So it was a very critical migration. And I think at their sort of staff volumes and their ability to observe the problem, they brought incredible engineers to bear. And those folks worked with us for months to lay out the plan before we were moving any bytes. Compare that to something done a little more slapdash, a little more haphazardly, a little faster, and you get the results that you get, right? So
Mm,
I think there are plenty of places where businesses go too slow, where they're
yeah.
ready to overinvest in the risk management because they haven't done the modeling of what the cost benefit associated with a faster migration is. But if you don't have that modeling done, that's a strong indication that you should probably take the slow boat and do it carefully, because who knows what the effect would be.
Yeah. You also mentioned, rolling back, like the ability, obviously you want that rehearsed. You want to be able to, like, I can't think of approaching a database migration without a rollback strategy, right? I guess it gets to a point, maybe at some point in time, maybe you've synchronized all your sequence numbers or your sequence IDs and, there's no going back. But
Mhm.
yeah, I think having yeah, I spoke about it then as well, like rehearsal. Like you gotta rehearse, and you were talking about modeling. I think that implies some form of planning and maybe testing of the target infrastructure that you're actually migrating onto, because often, I think these will be all traps for new players to this space, right? People would say, "Oh yeah, it ran fine when when there was no concurrent load on it," and but we didn't take into consideration that the S3, I don't know, snapshot restore of 100 terabytes, it didn't take hours. It actually took 6 days. I'm not speaking from experience, but that similar to me has happened. Like there's things that you just can't account for. So what are some other strategies people can do to try and get around these problems that are going to pop up?
Sure. I mean, I think fundamentally this is about creating experience and expertise
Mm,
around each of the steps of the transformation. So of course you have to rehearse, of course you have to practice. Really conveniently, a lot of those steps feel an awful lot like the operational maintenance that you should be doing on applications anyway. High availability rhymes with migrations, with rhymes with backups, right? Like all that stuff is a lot of the same kinds of motions. And so, if you're trying to like justify spending a little more on the preparation work or the planning associated with the migration, you can sneak that stuff into what it really is, which is better high availability design for the overall system, even after it's been migrated. Those practices will carry forward. Uh, I think it is a useful thing, and I think an important thing to explore, especially as you get kind of closer to the sort of final moments, together with all of your providers, being able to do as much of the kind of testing of these systems at full scale as possible. So you're talking about how long it takes to get data back from S3. Turns out that varies based on how much data and from which places, and so the closer to the actual migration you can get, the more accurate your understanding of the timelines are. The only facsimile you have for that is experience. So whether that's your cloud provider or your infrastructure provider laying out, this is what's typical to you, you're going to want to test what they say is typical in ways that you have the ability to, so you can tell whether or not they're telling you the straight line, or whether maybe their data is a little out of date based on the performance of these real systems today. We certainly found discrepancies there. And being able to partner up with folks that are doing this all the time, I think while it is the kind of thing that almost every engineer is going to have to go through once or twice, that's very different than what your job as an engineer is doing migrations. So like, my business and businesses we compete with, at any given time, we're doing 5 or 6 database migrations today. We're gonna do hundreds of them by the time this year is over. And being able to talk with folks, even just an hour, with somebody that's done this more than once, can really, really break down some of the impediment, especially as you can net that down to, I'm trying to move from DynamoDB to ScyllaDB. There's like a hugely more specific engagement that sets up for more prescriptive examples of exactly the steps that you would take to do that successfully.
Yeah, and it's, I guess, I mean, from my own limited experience, I've done a few database migrations, and mostly like for like, not switching
Mhm.
vendors, but just like switching, where it's hosted, that sort of thing. I always found that having like dual writes, single reads, and just being able to switch over when you have that, when you're comfortable that both systems are up to speed, or even if you can't do that, then like replicated writes, like if the database technology doesn't let you write to two places, then streaming them writes in, say, via CDC or something similar. I always found that they were good strategies to get that confidence, that source system and target system are behaving the same way. You can sort of see how they behave under load before you start servicing read traffic. Would you say that they're generally good approaches, or does it just come back to it depends, like you said at the start?
Yeah, I mean, I think the biggest driver of it depends, because I do think those are sort of generally good concepts. You are always going to want the split writes when you can, so that you are starting to even just build operational experience with the new environment under write load, which is its own thing to know as you go through this process. But I think very often the kind of sample architecture diagrams and the sort of sample code you might get from, in Terraform or others from, shows this stuff as far simpler than it usually is in practice. Most companies do not have one application hanging off of their one database. No, they have like 50 applications cross-talking
Yeah.
across 5 different databases and 2 warehouses and 3 different caching layers and all the rest of this. And so important as you get to like starting to take read traffic, that's starting to take all the read traffic from all the different sources that do this kind of reading. Some of them do it, you can imagine the relationship between a database and a data warehouse, where you may have some sort of scheduled extraction that happens on a regular basis. Some companies don't want to pay for streaming, warehouse replication, things like that. So, does the load change at a certain time of day when all of a sudden this other part of the workload shows up? That's a good reason to run testing for maybe longer than just the instantaneous read that you get right after the migration is completed, or right after the initial writes have moved to the new environment. There's also a lot where very often the operational characteristics of the new platform are very different than the old platform. That's the whole reason you're adopting the new platform.
Yeah.
And so you may have unintended hard-coded behaviors from other systems that don't comport with that. I remember working on a platform that had a bunch of alarming built around transactional throughput that drove pauses in CI/CD deployment, pauses in sort of upstream changes, when the reality is they were expecting, if some system on your side was doing 10,000 transactions a second, it's full of it and it's not actually doing it, and that's an error, and you should alarm on that, when the reality is the system could now easily do 100,000 transactions a second, and that's the whole reason we were adopting it in the first place. So you got to check not only the actual performance of the system, but what performance the rest of your tools and environment anticipate, and to what degree that stuff is encapsulated in automation that may or may not work in this environment. So good to be systematic in your evaluation of all of those upstream and downstream dependencies.
Yeah, really good points there. And if I was to sort of like summarize the effort, I think there's like a massive kind of discovery, planning, preparation, testing, getting confidence phase. Maybe running dual infrastructure, whatever, depends on the use case. Then there's often, like, whether it's big bang or not, there's going to be like some very fine, hopefully fine, DNS is pretty unforgiving, but the switch, the cutover, and maybe that's done in phases. And then there's an equally long tail of like confirming that everything is right. Like you said, different platforms might have different monitoring and alerting strategies. The observability tooling might be different. How do you do query traces or profiling, all that sort of stuff? Like, you don't what I'm trying to say is, you don't want to be, I think maybe the buildup is so intense that the day or days of cutover are also equally tense, but there's no relief, right? You can't just take your foot off the pedal. Um,
Well,
there's going to be follow-up actions that you have to be prepared for.
yeah, I'll say, thankfully, because I have been through plenty of these where the driver from migration is exigent, right? Your data center's imploded, the vendors yanked the contract, the all the drives in this region have gone offline. Like there's a whole bunch of reasons where you end up doing migration without any of this planning because it's emergency. But in the places, especially where the business is driving that decision, if you haven't gotten down to a place where the actual day where the actual DNS entry changes or the system of record flips over or the front end is refreshed to interact with the new system, if that's not boring, then you've done something terribly wrong. And it should feel really relaxed that day. Earlier days where you're trying it out for the first time and you're giving it the dry run 1.0, like, okay, yeah, maybe that's a little bit of a tight wire act. But we've done hundreds of these now, and the vast majority of them are very sleepy, right? Like the vast majority. Otherwise, we're just doing a bad job. So maybe there are business stakeholders on the other side that are biting off fingernails, but that's what being able to do this confidently requires.
So you've achieved Zen, is what you're saying. If it's
Zen, yeah, Zen in the art of database flogging. Yeah, that's it.
So if you're not feeling sleepy, then you're doing it wrong, is what you're saying.
Yeah, across more than just database. I mean, it is a critical part for most operations folks is to make this stuff as boring as possible.
As boring as possible. Go slow to go fast, or whatever other phrases we can squeeze in there. So we've spoken about the why. We've spoken a bit about the how. And I know that we can't recommend best practice, and that totally makes sense to me, because once again, it depends on the context and what you're moving. What about the stuff that you've seen that people just get wrong? And I'm sure you've made mistakes as well, but where are people likely to sort of screw this up?
Well, I think it's especially in today's environment where there are new tools every 90 seconds, right? Gemini put out their new models 90 seconds ago. We're all running off to test them. There's 100 startups in roughly this area that get founded every day. And the reality is some of those tools work really good, but like, I'll give an easy example. It's actually on the wall over here. Like I built this technical system at AWS together with incredible engineers for powering a bunch of the backend systems for the Obama campaign in 2012. And there was a kind of a hurricane coming to US East. And it was, seemed like kind of a good idea that since, maybe the region could go offline, we should probably make a copy of it to the other side. And I remember Bill set up and said, well, this isn't hard. We will use, trusty SCP to move data from one side to the other side. And I was like, bud, that's nuts. SCP is a TCP channel. It's not UDP. We're moving gazillions of bytes. Like what are you talking about? You got to try this thing. Or like, this just came out. We got to give this a shot. I think I was using Tsunami UDP at the time at one point. And, bytes per second on my screen were way better, like ridiculously better than Bill's screen. And then I'd grabbed the wrong set of file prefixes, or the machine I was filling full of bytes, and the drive would get wrecked and I'd have to get a new machine up. And, then we exhausted the east-west throughput for Amazon globally at that point. And like that caused the problem. And meanwhile, Bill's over in the corner running over the normal network on SCP. Those bytes just keep moving. Man, so like about half of the stuff we backed up, I moved, and about the other half he moved, where I was moving bytes 2 orders of magnitude faster than he was. So, I think it's critical that you get mastery over the tools. Is a rare commodity, and the more you can build it and use it in these situations, the better. I promise, like right in the middle of the plan, chucking some random new thing in there is not a recipe for success.
Yeah, I think I feel like I've been in that position before as well, and then you're midway through the whatever shifting bytes, and you're like, hey, we could make this quicker, and then you have that awful decision of, do I stop this async process going, or do we start all over again? And you're doing spreadsheets, and how many more hours delay to the customers? I mean, it's easy to get this stuff wrong. I think we mentioned, or you mentioned, underestimating scope and complexity. I think that's probably like a really common common mistake. It's never really going to be, we'll just shift it and make it run. Like it's these things can draw out to be quite big efforts, sleepy efforts, but extended in my experience. No clear rollback plan. You said that. I think don't have a rollback strategy. Any other sort of execution mistakes? Obviously copying data around. What about tools?
Well, I mean,
Go-to
generally,
tools that you
like
use? Yeah.
it's pretty hard to feel confident in this stuff if the majority of it is click ops, right? Like, the more you can reduce this to infrastructure management code that you can check in and test and run more than once exactly the same way. There's some systems aren't set up modern enough to really be able to be managed that way, but you just bear more risk at every step if you haven't figured out how to take the behaviors that you want to have happen and make them automatic.
And what about things like I don't know, data validation? Do you see that going wrong, or is that,
Yeah,
I mean, it
I
seems like
mean,
an obvious thing.
it feels more like that gets run into when you're making a more extreme change between
Mm,
database types, right? I think we had a lot of experience with folks trying to figure out what validation even really looked like as you were moving from kind of relational to non-relational environments, or moving from stuff that supported indexes to stuff that didn't, right? Like those kinds of structural differences mean validation gets sort of harder. Like um, you know, having sample queries, having kind of, what is the truth data you want to bounce against, all that stuff is really critical.
yeah, cool. So I guess we're coming to the end of our allotted time. I feel like this is a pretty cool topic. We could talk forever. Do you have any anecdotal war stories that you want to share with the audience, just to show that we're all human when we're doing this?
Oh, sure. I've blown up 100 things. Put just literally used the wrong dash in a database name entry, and dropped a whole bunch of tables I wasn't supposed to drop, and had to go back to the coldest of cold archives and find these things, and slowed the whole process down. I certainly did my own fair share of blowing things up. And a lot of that, frankly, hung off of an environment. I wrote one of the very first CloudFormation templates in AWS, and was like a constant whip cracker around. This is pretty great. It means like the stuff you do just like actually comes out the other side automatically. So I did a lot of tight wire acts with customers, driving around. At the time, early with AWS, they didn't even have a console yet. So you're off
Yeah,
driving around right scale, or doing a bunch of, I had Apogee open doing API calls against
yeah.
the APIs to be able to try to make some of these changes. So, be thankful, new developers, as these tools have gotten radically easier, and frankly, like much more repeatable. But no, it's the ones that I remember best that are the most fun are the places where it's the opposite. We did this great migration with the folks at Digital Turbine. They were on Dynamo. And it was just like the plan seemed clear. Their dependencies were very simple. Their throughputs were high, but the actual like connective tissue was low. It took 2.5 weeks. It was all buttoned up, done. Everybody had a beer in the middle of the thing. It was so obvious it was going to work great. I mean, super, super simple when you get it all hammered out right.
Yeah, well, thanks for that. That's a nice segue. That's a great case study as well. We'll link it in chat, and so people can have a look at that. And yeah, I think there is that sort of sweet relief, isn't it? Like when you get it right, and it's been rehearsed, and that post implementation review, everything's good and customers happy. It's always a good feeling. So I guess my advice is, if anyone's listening and scared of this stuff, is just to have a crack, because it teaches you a lot about distributed systems, or it teaches you a lot about your own architecture, because there's often lots of little surprises in there that nobody knows about. So it's good fun to get your hands onto. I think that's all we've got time for today, Miles. So thanks again for joining us. It's been an
Absolutely.
absolute pleasure talking to you. And yeah, there's lots of good tips there. We'll try and summarize some of this in a blog post, and maybe do something similar in future.
Perfect. Happy to help. Thank you, everybody. I appreciate the great questions, Tim. That's fun.
No worries. See you guys.